Alright, so our objectives for today are to estimate integrals using quarter circles, semicircles, trapezoids, triangles, and rectangles, and then interpret the meaning of integrals and derivatives of rates of change in context. So what I have here is a graph showing the velocity of an automatic vacuum cleaner in meters per minute. I want to find the total distance that the vacuum cleaner traveled in the first 5 minutes. The displacement after 8 minutes and acceleration after 6 minutes. Okay, I've got a lot of feedback actually. Let's see, Kelly, can I ask you to mute your mic? Okay. So total distance vacuum cleaner traveled in the first 5 minutes, and displacement after 8 minutes, and acceleration after 6 minutes. So what I'm going to do is we're going to estimate the area underneath this curve using basic shapes. So circles, triangles, trapezoids, and rectangles. Because this is already measuring velocity, meters per minute, when we integrate, we'll end up stepping up this chart. So if I integrate from velocity, we will end up with displacement. Okay. Integrate from velocity to get to displacement. Integrate from acceleration to get to velocity. Integrate from jerk to get to acceleration. When we integrate, we'll always step up. If I derive, then we'll go down. So I could derive to get from displacement to velocity, from velocity to acceleration, or from acceleration to jerk. Okay, so to integrate, I'm going to split this up into a bunch of different areas, which I've got here, color-coded. So I've broken this up into this green area as a triangle and a trapezoid. This pinkish area is sort of a cutout of a circle outside of this box. I've got a blue area as a triangle and a yellow area as a rectangle. So let's get this green area first. Sarah, what should the area of this green space be?
Green space?
Yep, so okay, if you want, we can split this up into the triangle and the trapezoid. So what's the area of this triangle on the left? Nope. Lost Sarah. And she's back. Okay, so I'm going to split this up into two separate areas. Let's do this triangle on the left side, still in green, should be how many units? So what's the area? Okay, I've got Sarah dropping in and out. What's next on my list? Eileen, what's the area of this green triangle?
Three.
Okay, so I've got a 2 by 3 triangle, so that's 1/2 of 2 by 3 is 3. How about this yellow area?
25.
Okay, 2.5. Okay, for this pink area, it's a little bit more interesting. If I focus on this pink area, I've got a box that I could draw here. I am cutting out a quarter circle out of that box with a radius of 2. So if the area of a circle is pi r squared and I'm cutting out 1/4 of that area, I'm cutting out 1/4 of pi r squared where r is 2. So that's 1/4 of 4 pi is just pi. Okay, the whole area of this box would be 4 units. So this pink area should be 4 minus pi units big. So our area here is 4 minus pi units. Okay, then these areas are underneath the curve, so that means they're actually going to become negative. What's my area in blue?
4.
Okay, and that's a negative area, so this will become -4. And this area in yellow?
-4.
-4 again. Okay, any questions on how we got the areas? The pink one's kind of the only weird one here, I think. Alright, so again, when we're getting these areas, we're multiplying our y times x. So in that case, it's velocity for our y value and time for our x value. When we multiply velocity by our time, we get displacement. So if I want to find the total distance that the vacuum cleaner traveled in the first 5 minutes, then I could add up these areas. Or 3 plus 2.5 plus 4 minus pi. So that gives me 3 plus 6.5, or 9.5 minus pi. Would be my total distance that the vacuum cleaner traveled in the first 5 minutes. Okay, if I wanted the displacement of the vacuum cleaner after 8 minutes, so for displacement, that means my direction does matter. So I'm going to keep these negatives negative when I add. So this will be the -4 and the +4 here can cancel. So I'm left with -4 minus pi plus 2.5 plus 3, or 1.5 minus pi. If I had asked you for total distance traveled after 8 minutes instead, then all of these negative areas would have become positive, because if I'm looking for distance traveled, we don't care what direction you were traveling. I'll jump in for that really quick. So we mentioned this in quarter 2, but it's been a while. Okay, back in quarter 2 we said something like, if you had a house that you started at, and then you went over to, we'll say, a basketball court. To go play basketball and maybe I don't know, a restaurant. So I'll give us distances. This will be 10 kilometers from home, at home, 15 kilometers away. If I was looking for the total distance traveled, if you went from home to basketball to a restaurant, what would my total distance traveled be? So we went to basketball and then to a restaurant. How far did we travel total, and what's our displacement? What else do I have with this? I've got... Okay, I've got Kyle and I've got Tommy. Tommy, how far did we travel total if I went from home to basketball to a restaurant?
Can you repeat one more time?
Yep. What's the total distance traveled right now if we went from home to play basketball and then went from basketball court to a restaurant?
5 kilometers.
5 kilometers would be my displacement. So I can say displacement is negative 5 kilometers. 5 kilometers to the left. What's our total distance traveled though?
25.
25 kilometers. Perfect. Okay, so for displacement, your direction matters. Displacement tells you your distance from a start point. For your total distance traveled, direction does not matter. Total distance traveled is like the odometer on a car. No matter what direction you travel, you're still adding miles to your car. Okay, so that's the same thing that's happening here. When they ask for displacement, they're asking for how far the vacuum is away from the place where it started. So in that case, these areas become negative, which just shows direction. If we're looking for total distance traveled, then everything is positive. Even when we're looking for positive area, though, I will still have a 4 minus pi, because that minus pi is really cutting the white space out of that box that we had originally. So for this box, our white space here is pi units out of the 4 units that we had for the box. Okay, if I wanted to find acceleration after 6 minutes, then because this is a velocity graph, I would need to derive. Kyle, how could I derive this function at 6 minutes?
The m function?
Yep, so I've got this function that we're graphing right now. How could I find the acceleration at 6 minutes if this is a velocity function?
Meters per second squared. Velocity. You could divide by time.
I'm going to divide by time. Okay, so I want to derive, which would be my slope at a point. How can I get the slope at t equals 6 using this graph?
But by using the slope and how do you call this? Wait, no. Rise over 1. So it's y2 minus y1 over x2 minus x1.
Okay, cool. And that would be true for all of this blue part of the line. So let's say our rise was we went down 4, and our run was over 2. And then my slope would be negative 4 divided by 2.
-2.
Okay, so that's -4/2 or -2. Okay, any questions on what we did here? Every time that we're deriving, we're really getting a slope. You can use rise over run if we've got a line. Anytime that you are trying to find an integral, so trying to work backwards, get from velocity to displacement, from acceleration to velocity, from jerk to acceleration, we'll be using areas. If you're talking about a vector, so distance from a start point is displacement, then you'll need to keep your areas negative if they're below 0. If you're not talking about a vector, so something like total distance traveled, then you'll need to make all of your areas positive before you add them together. Okay, so let's try a little bit harder. If you freeze, this is... I'm just going to do the other one. We'll do the graphical integration challenge one. And leave the easier one for homework, I think. Okay, so I've got another graph that we're using. The x-axis is time, the y-axis is f of x, and for questions 1 through 9, f of x is velocity. The displacement at t equals 0 is 0. Okay, so I've got a bunch of questions here. Before I do that, I'm going to break this up and we'll talk about areas again. Okay, so I've broken this up into a bunch of different colors again. If I get my areas, let me do the harder ones and then I'll flash everything. So these green areas are just a box and a triangle, but this triangle is a little bit weird because we don't have this breaking off at an integer value. So what we can do is we can use this slope to figure out how far away this point is that we're crossing at. So right now I went down 1, 2, 3, 4, 5, 6 units and over 1. So my slope is -6. So if that was true, and my intercept was, we'll say here at +2, so I'm shifting my axis over to see how far over this would be. Then my equation would be 2 minus 6x, and I would hit 0 at 1/3. So that means this distance, oops. This distance from here to here is 1/3 of a unit, which also means this distance from here to here is 2/3 of a unit. I'm going to leave that one up, I think. This distance is 2/3. Okay, so that means this purple triangle that I have here, this really, really small one, has a base of 1/3 and a height of 2 units, because it has to extend up to here, where the yellow space ends. So my total area for this purple triangle would be 1/3. For this yellow space, I've got a part of a circle. This is 1/4 of the area of a circle. 1/4 of pi r squared. Where my radius is 2. That means my radius squared is 4. So this is 1/4 of 4 pi, or just pi. Then I've got a triangle here. This base is 1 plus 2/3 or 5/3 with a height of 4. So this would be -10/3 for my area here in green. Then for my hardest part of this is this box here. This quarter circle that I have here in white space is again 1/4 of a circle with a radius of 2. So this white part is pi. The whole box area is a 2 by 2 box, so the whole area of the box is 4 units. So if that's true, this space in pink would be 4 minus pi units, and it would be negative because it's underneath the curve. So we could say this area in pink is negative 4 minus pi. Okay, this area in orange, if I split it in half, is my rectangle with 8 units, and this semicircle, this is half of an area where the radius is 2. So my total area of that circle, if I completed it, would be 4 pi. Half of that circle would be 2 pi. So this total space in orange is negative 8 minus 2 pi. Okay, then a normal triangle and a normal rectangle. So this normal rectangle is 6 units. And that is negative because we're underneath the curve. This normal triangle is 1 by 6 is negative 3 units below the curve. Any questions on how we got areas here? All right. So I'm going to copy these areas and we'll start answering questions. Okay, first one asks, what is the speed 2 seconds before we started if this graph represents velocity? Okay, so 2 seconds before I started, 2 seconds before we started. If my speed is velocity without direction, then that's the absolute value of my y value. So the absolute value of my velocity right now is 2. So this is the absolute value of 2. Or we could say speed is the absolute value of velocity. Or 2 in our case. Okay, if I want acceleration 5 seconds before we started. If this is velocity and I'm looking for acceleration, what do I have to do to find it? Kelly?
Can you repeat the question?
Yep, so if this graph represents velocity and we want to find acceleration 5 seconds before we started, so that's 5 seconds before 0, what would we have to do? How can I get from velocity to acceleration? want to integrate or derive?
Derive.
Okay, I would want to derive to get from velocity to acceleration. At 5 seconds beforehand, 1, 2, 3, 4, 5. I've actually picked a bad point because that's right in the middle there. So I don't actually have a derivative here. Let's do 4.5 because we will be able to solve for that. So if I did 4.5 seconds before we started, and I wanted to derive, then I would find the slope of this part of the line. What's the slope of that line? Let's go. Can't really see who JK is. Jana. So I'm going to find acceleration. I'm going to do 4.5 seconds before we started, which is on this interval between -4 and -5. What's the slope of that line?
Sorry, I can't hear. Can you repeat the question?
Yep. So if this graph is velocity, we're looking for the acceleration 4.5 seconds before we started, which would be on this line. What would my
The pink.
acceleration be?
The slope.
The slope? Okay, what's the slope of that part of the line? So slope of the line between -5 and -4.
Hello, I can't hear.
What is the slope of this line? Nothing. Okay. Lost Jana. Anyone, what would the slope of this part of the line be? From x equals -5 to x equals -4.
The screen is black.
Okay.
Sorry.
I'm gonna... Do I have everyone else with the screen black, or is it just Jenna?
Not me.
Okay. So Jenna,
Yes.
I think it's your connection. If you've got a VPN, if you can drop and turn it off, you might be able to come back.
Okay.
Okay. So I need to get the slope of this line. My rise is 6, my run is 1, so this is going to be 6 units. So my acceleration, 4.5 seconds before starting, we said, was going to be 6 units, as the acceleration is the derivative of velocity. I think I'm just going to run through the other ones as fast as I can. So I'll get through 9 at least. My displacement 6 seconds before starting. So that would be how far away from the start point I was 6 seconds before we started. So here's 1, 2, 3, 4, 5, 6 units. Means I'm going back all the way here. Because I'm working backwards, all of my signs are going to change. So that means this will become positive 10 thirds minus 2 thirds is positive 8 thirds minus pi. Minus 3, which is 9 thirds. Add here. Actually, I can just type. Okay, so we went back 10 thirds. I went backwards, which is negative, by a negative, so that makes it positive. Okay, minus 2 thirds because I'm going backwards, minus pi because I'm going backwards, plus 3 because I'm going backwards, and plus 6 because I'm going backwards from 0. Okay, 10 thirds minus 2 thirds is 8 thirds, 3 plus 6 is 9, so I have 8 thirds plus 9 minus pi. 9 is 27 thirds, so I've got 35 thirds. Minus pi should be my displacement 6 seconds before starting. Okay, that means if I'm 35 minus pi units away, and then I go this much displacement, negative 6, negative 3, pi 2 thirds, negative 10 thirds, it should be back at 0. Total distance traveled 6 seconds after starting. Total distance traveled doesn't care about direction, so I'm going to take all of these negatives and make them positive. So instead of negative 4 minus pi, this will be positive 4 minus pi. Plus, if I'm going 6 seconds, that's all the way to the end here. So I'm going to add 8 plus 2 pi. So that gives me 12 plus pi. And then if this is velocity, find the integral from negative 6 to 6. So if I'm going to start at negative 6 and go to 6 by displacement, will be what happens if I add all these areas together. So that would be negative 6 minus 3 plus pi minus, plus 2 thirds minus 10 thirds plus, okay, that's negative 6 below the area, negative 4 minus pi. Minus 4 minus pi. Okay, minus 8 minus 2 pi. So we're adding all of these areas, and if it's negative, we're keeping it negative for displacement. So units for displacement could be meters, potentially. If I wanted to change that so that I was looking for total distance traveled instead, then my total distance traveled would be what happens if I take the absolute values of all of these areas. So all of these negative areas would become positive. If I wanted to get the derivative at x equals 4, 1, 2, 3, 4, this is a minimum, so my slope should be 0. And that would represent my acceleration if this graph is velocity. Okay, and that gets us through 9. Any questions on anything we did so far?
No.
No.
Okay, so I'm going to stop here. I've got the other packet that's in here that I want us to try. So that's graphical integration and graphing trig functions number 2. So the one that does not say challenge on it, it looks like this. So I'm going to take that one up for homework on Thursday at 9 a.m. Thursday because we need to go 2 days after our A-Day class has a chance to check. If you've got questions, please message me on MeChat. We still have the Riemann sums homework that's due at 9 a.m. tomorrow on Tuesday. I'm also going to start sending back quizzes as soon as our class finishes here. So that was our nonlinear regression quiz, which was graded over the weekend. So that's in gradebook now, and you'll get your feedback in a couple minutes. Okay, thanks a lot for coming. Sorry we're a little bit over time. If you guys have questions, you're welcome to stay for a while. If not, you're free to leave.
Mr. Brandon,
Yes.
can you please repeat question number 5? I couldn't see the thing because it was black, so.
Okay, so question 5 says, if this function represents velocity, find the integral from negative 6 to 6.
Okay.
So if this is velocity, then And I want to integrate from -6 to 6. And I'm going to add all of these areas together to get my answer. All the way from the left to the right. So that would be -6 plus -3 plus pi plus 2/3 plus -10/3 plus -4 minus pi plus -8 minus 2 pi.
How did you get -4 pi for the area?
-4 minus pi for this pink area.
Yeah.
So if I look at this, box that I've cut out, this box would have an area total of 4 units, right?
Yeah.
Okay, and then I'm cutting out this quarter circle, which has a radius of 2. So the area of a circle with a radius of 2 would be pi r squared, or 4 pi. 1/4 of that circle would be 1/4 of 4 pi, which is pi. So my white space here is pi. So that means this pink space should be the total area of the box, 4, minus the white space, pi. So,
Oh, okay. Okay.
and then that area must be negative because that negative sign shows direction. We're below 0 right now. So that's -4 minus pi.
Okay.
Cool.
Thank you.
No problem. Catch you later.
Bye.
Goodbye.